Okay, so yeah, this is a document. The date actually is something like 2.5 years ago, and it's pretty updated. And this shows how to use the Ethernet IP with Trio. Yeah, it starts with the EDS, which is the electronic data sheet, which you need from Trio, and you can find it from Trio website. Uh, Let me just
Okay.
bring up the Trio website. If you go to Trio website to product, for example, for Flex 6 Nano
Yes. Let's see.
over here,
Okay.
if you go to the support page, okay,
It's not control.
yeah, in support page, actually, you can see this is the EtherCAT extension file as a slave, EtherCAT document, and here
Okay.
you see that
Yeah.
Ethernet IP EDS. So this is the exact EDS one. You have it for every controller.
Okay. So
This is for Flex 6 Nano.
oh, okay. If I want to use an M402, for example, or free, I think I need another file, right? It's
Okay,
different
sorry,
file.
say again. I didn't get you.
Okay. If I want to use, for example, and I don't remember who. Let me check where is that here?
What is
Uh,
M?
for example, if I want to use to connect for Ethernet IP and MC403,
Okay, 403. Yeah,
it
yeah.
have
If you go, yeah,
its
if you
own.
if you want if you want to have M403, actually you should go to product and then MC403 over here, and then again support, and you have a specific, yeah, you have a specific file for Ethernet IP over here. You
Support.
see that?
Okay. Yeah, okay.
But yeah, by the way, different models actually have different files.
Different files.
Yeah. So if you're using MC403-Z, you should get this one. 403 itself should be this one. Oh, this is for DeviceNet. This is for Ethernet IP. Yeah. So if it's only MC403, actually this one should be good for you for Ethernet IP. We have another file for DeviceNet as well
Okay.
over here. So yeah, it's available for every type of controller separately because the mapping are different.
Are different. Okay.
Yeah, specifically for that type of controller. Yeah.
Okay.
Now I'm not talking about the mapping like accessing the VR variables. That's different topic. We always keep standard. You can access through Ethernet IP to address 4000. So it will be VR0 mapped on the address of 4000. Let me show you
Okay.
here. If I go to the mapping, here's the mapping for the 16-bit address. Okay, and this is mapping for 32 bits address. So this is the address for reading, writing
Format values
over Ethernet IP, and they all start from VR0. So 4000 actually will be VR0. This mapping. Let me see if there is an example here.
common TCP Ethernet.
Data formats. Okay. Yeah, this is an example for setting up the Ethernet IP. Change. This is for RS Logic 5000 software setup. Because
Okay.
because when you use the Ethernet IP, actually most of the job you need to do it at the PLC side because the PLC is supposed to be master. So this is all the settings through this ABPLC menus. Okay, so there is a step-by-step instruction explaining how to set up at the PLC side to recognize Trio. You see here, after adding the EDS one, actually you will have the Ethernet module Trio communication over here, this one. And then you will go step by step to set it up. You see Trio here?
Yeah.
This is the name appears on the RS Logic side after adding EDS file.
EDS file.
Yes. And then this is another example for communicating between Omron CJ2M and Trio controller MC464. This is also Ethernet IP because the Omron also can be the Ethernet IP master. So this is all the setting for different PLCs. So I can send this document to you if you want. And you can also get it from website easily if you go
where
to Trio website. If you go to
found it in
if you go to resources, and then if you go to resources and all documents, of course you need to log in. Okay, continue, and then you type Ethernet IP like this, I believe. You type Ethernet, which is more
Ethernet
general, and it bring you a bunch of documents. You can find the Ethernet IP document over here. You see that?
Yeah. Okay. See.
And you can download it from here.
Depends on the contract. Wait, Ethernet PUDP, Ethernet functions, Ethernet PP. Okay, here.
Yeah, that's it.
Oh,
so in the document, in document actually you can see some screenshots and some step-by-step processing. This is for Omron. The previous one was for Allen Bradley, like this.
Mm-hmm.
And Trio UK, the engineers are working on an AOI, which is kind of plug and play to Allen Bradley PLC. So after having that AOI, you will be able to connect Trio controller to Allen Bradley plug and play, and we will have a document for that, which set up all the necessary communication and everything automatically, so you don't need to do anything on that. Just plug and run it, and just pick the right address on the PLC side. That's it. It's very easy actually. I had one customer 2 weeks ago. They also they plan to connect the Allen Bradley to our server through Modbus RS485. They had the module, and they did it very easy. So so it's ready made. Okay. So actually we can start with interesting topic for DX4, which is the second encoder connection to the DX4, or we can start with your question and answers. Which one you prefer?
We can see some of the drive.
Yeah, if you want, I can start
the topic,
because this is the new topic for you. So I would like to share this function also with you, to be aware of that. This is a very nice function. Actually, in this case, the DX4 will be a double axis. The first axis will be the motor, which is connected to the drive, and the second axis will be the encoder, which is connected to the DX4 X7 connector. So basically, if I double click on that, it gives you one axis for the motor and the second axis for the encoder. So this is the case. So I have an encoder here connected to the DX4, so I can actually activate it very easily. What I need to do is actually there is a network configuration for DX4. Okay, so you can go to network configuration and there are some ready-made options over here. Okay, but there is also a custom defined profile that you can pick whatever you want, regardless of the existing one, because the existing one is already mapped with some options. Okay, so you want to do something out of this list with a combination of the favorite registers and objects which are available on the object dictionary. You can go through define custom profile over here. Okay, and then you can pick whatever you want from here, from this menu, include the second encoder. Okay, the second encoder actually is placed on DX4. So let me show you again. Let's go to user manual of the DX4. DX4 user manual, which is here. Okay, so if I go from the option menus, we can go for fully closed loop, which is this topic. So there are different options here. You can connect an external encoder and define it as an extra access, but just an encoder to read it freely separately from the drive and motor, which will be the extra access as I showed you earlier. Or you can use it as the second encoder, which is installed on the axis, and the drive actually read that encoder instead of the motor encoder. So in this case, actually, if you have any backlash or any basically for the backlash, actually they use the second encoder because sometimes the gearbox and the mechanism which connected the motor to the real axis is not so accurate. Especially for retrofitting, this is very good option for you. So these four actually provide you the built-in function, just like Kollmorgen AKD. Okay. So in this part, I want to show you how you can use a separate encoder and how you can connect it and how you can create a profile to read the encoder in DX4. Okay, which is available in the hardware. Let me show you. You can connect physical encoder output to DX4 on this connector. Okay, you see PI A plus, minus, B plus, B minus, C plus, C minus. These are the connectors that you can connect the encoder, okay, through these pins. And the actual pins also are here in 19, 20, 21, 22, 23, 24. And it also generates the power supply for the encoder, which is max 500 milliamp, which is quite enough for most of encoders. The point is actually you can only connect the line drive encoders, which is compatible with these configurations over here. So it's incremental line drive 5-volt encoder. This is the only option for that, which is fine because most of this is a very popular type of encoders in most of applications. Okay, and in this case I already connected an encoder, so let me show my second camera over here.
Okay.
I already connected this encoder to DX4. by using this connector X5, X7. So the encoder is already connected, and what I need to do is I need to go through network configuration. So for this, first you need to run the EtherCAT, so you have the communication with the drive, okay? And then you need to go to the drive menu and then go to the network configuration and go to the configuration option over here, okay? And then you need to open up this combo menu and then use the define custom profile, okay? In this case, actually you can checkbox whatever you want from here. Let's keep it simple. Control word, target position, status word, status, actual position, and then second encoder, okay?
Second
And then
one.
yeah, and it will offset one axis with the existing axis of the DX4, which is in this case is axis 3. So we will have the encoder as axis 4 after creating this profile, okay? And when you activate it, it will set up this type of the configuration for PDO, and you see the axis 4 is additional axis on the DX4 with only actual position of the encoder, which is a 4 byte, 32 bits, okay? And there's nothing else. While for the axis 3, which is the actual driver motor, you have the control word, target position, status word, and status position, exactly as we set it up. Okay, and then you can apply and save it to the MC config. In this case, it will generate a file called ECExtend. Yeah, first it will restart the software and restart the controller and restart the EtherCAT as a consequent process. And after that, it will create an ECExtend file, which is the additional extension file for EtherCAT configuration, and will attach to your project as a permanent file, just like other programs. And that ECExtend let the drive to have the second encoder and read it over EtherCAT. And it all happened automatically. Okay. Okay, you see it's here, and we have the ECExtend file over here. If I open up the ECExtend file, let me get rid of this, because I already made another profile before we start the training. So this is the previous one and this is the new one, which we just created a few seconds ago. Okay, so this is the contents of the ECExtend right now. That's good. And what you need as an extra step in this process is we can return to the drive menu, because for activating the second encoder we need to adjust the parameter on the drive. By the way, it will show up, I think, somewhere as a hint for us. Okay, let's get rid of this. There's a parameter called PN210. This is the external encoder setting on the drive. This is a part of the drive parameters. And for activating the second encoder, we need to set these parameters as 2. So the bit 0 need to be number 2. Okay. And after entering, because this is kind of essential parameters for the drive, we need to cycle power by using this button over here. Can perform a reset once servo is on. Okay, so we need to turn servo off, and then we can go through the menu again. Initializing device, so we start over there. Okay, let me do that again. No, let me reset the controller first. Yeah, this is a new option for us. So
Mm.
there is still some ongoing process to make it more functional and much more easier to pick. Uh, but this is very useful option for you. You can imagine in some project that you have some external encoders and you have the DX4. Instead of ordering a module to read the encoder, you can use the DX4 built-in function to read
Mm.
the encoder, which can save you a couple of $100 in the project.
Mm.
Okay,
Nice.
so I can go from this menu. You see, when you change any essential parameter, it will change the color of this button to yellow. It's kind of warning for you that you need to restart the drive. Oh, okay, sorry. I need to servo off.
Okay.
It goes to some. Okay, I need to restart the controller and then servo off and then try to restart the servo from that menu. I forgot to do the servo off. Okay,
Okay.
almost there. Okay. Yeah, because my startup program actually do the servo on the axis, so I need to servo off and then go to the menu. I restart the servo like this. You can do it by physical cycle power also. That's also the hard way, but the soft way, easier way to use the button over here to do that.
Mm.
Okay. Then after restarting, it will be ready to go. So if I go to the encoder, you see the value?
Yeah. Okay.
Yeah.
It's really in the corner.
Yeah. So once I'm spinning the encoder, the wheel,
Mm.
you see it counting. While I leave it stand still, stop counting, can go to the reverse, it will down count and go to negative value. If I go this way, it goes to positive value again.
Okay.
Turn it fast, so you can imagine in the real production line it goes something like this. Okay, so basically the drive counted the value and just the controller just fetching the value over EtherCAT. So it's
Yeah.
yeah, it's quite fast.
The drive is counting pulses or edge.
Oh, sorry, say again, please.
The encoder, the drive is counting the pulse, the complete pulse,
Yes,
or
yes,
or
exactly.
edge only.
It's counting the edge.
The edge. Okay.
Yeah, it's counting the edge.
Counting, yeah.
So this is this encoder I have here. This is basically 1,000 pulse
1,000.
per rev. I'm not sure if you can
Okay.
read it. You see here,
Yeah.
1,000 pulses.
1,000. Okay. So we see
Pulse per rev. Yeah.
4,000 counts.
Yeah. So what you see actually here is the actual position. Okay.
Okay.
So how we can count it, because it's also depend what you see on the depause menu.
Pulse.
Okay. Okay. One more step you need to do to add it to the this menu. You need to go to the select axis to display. You see it's waiting in the list over here,
Mm.
so you can add it to existing active list. Then you will have it over here in the axis menu. You see the axis 4? Okay. So since the unit is 1, it will count based on the pulses. So what you see here on the dpos is exactly the same value as you see on the actual position on the encoder menu. Okay,
Okay.
so let's do something like this. Let's choose base 4 over here. Okay, and then def pause 0. Okay, so basically we
Okay.
reset the value on the dpos, but you see the encoder value still remain unchanged because with this command actually we're just changing the dpos and mpos value inside the controller.
Deposit on it.
So this is kind of offsetting. Okay,
No.
so if I take the encoder as you see here, okay, and
Mm.
if I okay, let me show you the camera. Okay, let's do def pause again, just in case. Okay, if I show the camera, look at the value is 0. Okay, and then if I spin the encoder 1 rev, almost 1 rev, you see the value is almost 4,000. So it counting the edge basically, because this encoder actually generating 1,000 pulse per rev, so it come up with the multiplier of 4, so it counts 4,000 as you see here. You understand it?
Okay.
Are you with me? Yeah.
Yeah.
So yeah, so basically the edge actually multiplies by 4.
By 4.
So if the encoder is 1,000 pulse per rev, when you speed the encoder 1 rev, it counts 4,000 pulses, because you have up rising edge and falling edge on A and rising edge and falling edge on B. So you will have multiplier of 4. Okay. So this was an example for you how to read an encoder. This is very valuable option for some projects, especially for a low-cost project that they don't want to spend more money on buying more modules. If you don't have the DX4 drive and your drive doesn't have this functionality, for reading the external encoder, you need to buy a module called P375. It's almost 500, 600 bucks list price for the customers, which someone cannot afford it.
Okay.
Yeah. So yeah, this was some kind of the fancy functions for DX4, or if you have the total Trio package in your project, you can have these kind of functions very easy. So you can imagine each DX4 provide you one encoder, second encoder input. So for example, if for a double axis, 2-axis project, you will have 2 encoder inputs built in on DX4 on your server in this project, which can save you, some cost. Any question?
Okay. No. Very nice. Kollmorgen also have the same possibility to connect
Yes.
an external core, so we can use it the same like
Yes.
Okay.
Exactly. Yeah. If you go, if I show you the Kollmorgen options over here, for example, if I go Kollmorgen, if I choose the AKD, for example, the first one. If I double click on that, it show me this type of configuration. I believe it was profile number 4. Oh, actually for Kollmorgen is not so straightforward to use the second encoder. Okay, as I see here, oh, let me see. Yeah, the second encoder is not ready-made here.
Okay.
The touch probe is, but the second encoder is not. So you need to pass extra steps to create it,
Okay.
which is not as easy as the DX4.
Okay.
Yeah, so it's a little bit challenge, but it's still possible to do that because
So,
yeah, because for Kollmorgen actually you have we have an option here on EtherCAT. If you right click on that, you can import the ESI file. Okay, and in this import, actually you can import the Kollmorgen because I believe it will provide the ESI file each Kollmorgen drive, and you can import the ESI file from here. Okay, for example, I have the control technique.
mm-hmm.
Already exists. Okay,
Mm,
let me go through that existing option. For example, the Panasonic. Okay, if you import it, you will have the file there, and then you can double click on that, and it will let you. Okay, someone waiting here. It's Carlos. Yeah, Carlos is joining us. Okay, so here actually it will let you pick different control mode. Okay, and then you can build the objects. You can use the ready-made one, or you can build and add some extra objects you want. You can pick different options from here. Okay, and you need to go through this step to build your profile for EtherCAT. I believe for Kollmorgen should be like this because I can't see the ready-made option here. Let me double check if I can have the Kollmorgen. Yeah, definitely DX4 is much easier for you to have all of these options in a glance. So we have status for, so this is for digital input and output, which is ready. This is with additional actual following error. This is with touch probe. This is with actual following error, touch probe, and digital input and output. And number 5, in addition, you have the actual torque for and analog outputs and analog input, I believe. Yeah, so you have analog in, analog out, number 5, and also yeah, these are ready-made options for you. But for second encoder, I believe it has some challenge for you to build it yourself, but it's possible for Kollmorgen. For DX4 actually is something easy to use because this is all in Trio. They, created some built-in function for that.
Okay.
Yeah, this is the difference, yeah, between the third-party brand and the Trio brand if you use for servo.
Mm-hmm. Okay.
Any question here?
No. For now.
Easy. It seems easy, right?
Yes, easy.
Yeah.
I hope to.
Yeah, it is. Yeah, really, it is. It's easy. There's less challenge for you.
Yeah.
Okay, so I'm hearing your questions, and if you have any challenge or anything during your testing, you can tell me, and we can go through step by step.
I'm trying with a application.
Yeah.
It's a cutter. It's a cutter.
Do you want?
At the
do you want to share? Do you want to share your screen with me? I can stop sharing my screen.
I just make an example, program example. I don't know if it's possible to I send to you the projects and you
Yes,
can
yes,
open
you can.
it. Yeah.
Yeah, you can send it for me. If you go,
Me?
yeah, if you go to, yeah, if you go, you can email to me. Yeah.
Okay, perfect.
If let me
Send
let me show you something about this one. Um, see if I can. Solution. Not here. Document. Customer support. Formats. Test. Okay.
Okay.
You see that when you go to the folder that the project exists there, so you will see the bunch of files like this.
Yeah.
If you yeah, based on the file not file name that you already created, you can
Oh,
find them. Okay, so you can open up, right click the BAS file. You see the BAS file?
best.
This is the editor. So if you right click on that, you can open it with Notepad, for example,
Hmm.
okay, like this,
Okay.
and you can select all, copy, and you can send it by email.
Okay, I send the complete project, but I can send again only the text.
Yeah, exactly. Yeah, that's easy because if you want to send just one one program, actually, it's easier.
Or
If
yeah,
you if
any one.
you can also send this file, but the problem is some of the mail servers actually, because these are kind of the PC programming files, so some of
Okay.
the mail servers, ex- you know, doesn't let this type of the files goes through and gives an error for you. But simply you can save it as a notepad file and attach it to your email, or you can copy paste in the body of the email, which is
Okay.
much easier.
This is here.
Yeah.
Let me send only the. There there is one comment. Let me choose.
Which line? You can tell me the line number.
Okay, the line number.
Yeah, the line number is
Uh,
in the left
ah,
side.
the last one, the W doc.
Okay.
What does it actually do?
Okay. Yeah, the WDoc is we call watchdog, and
Oh,
the watchdog is exactly enabling the master enable for you.
okay, it's like the master enable.
Okay.
Oh,
Yeah, the master enable, enabling all the access together. Let me show you.
mm,
Uh, I have access 0 and access 3 as a server here. Okay.
mm-hmm.
This is stepper. This is server. So I have actually two axes, two motors here. Okay.
Mm-hmm.
So by default, it's disabled. So it's loose and I can spin them around with hand uh, by semaphores without any problem. But if I want to start the movement, actually I need to do the watchdog on. So I can go here and type in wdog
Oh,
equal one or equal on. Once I enter it, you see
oh yeah.
the master enable change the status and getting enabled. I can do that from here by clicking on this option.
Okay.
It's the same. But if you want to make it automatic in the program, actually you need to write it somewhere that processed by an automatic procedure inside the controller for you. So this is the way we can activate the watchdog.
Gosh.
So there is one more option for you. Sometimes you have multi-axis
Yeah.
in one project, but you want to activate, for example, one of them, not all of them, because the master enable or watchdog activate all of them. Okay, so there is another, uh, command called access, access enable or enable access, I believe. Yeah, access enable. You see that?
Yeah.
Okay, so access enable equal on for access 0. Okay, and you can do the same for the other axis, axis 1, axis 3 here, because I have axis 3 and axis 0 as an actual axis, here. So what happened is I can turn them off by default. Okay, because by default they are on, and while you once you activate the watchdog, they will get ready or servo on, all of them. But this command actually can give you an extra control one by one on each EtherCAT access for you.
Okay.
Okay, so in this case, if I do the watchdog on, I can type it here. So I can type the whole command just to save some time. Okay. Oh, actually here it doesn't work like this. Let me see. Oh, you know what? Actually, it's not like this.
Okay, access.
I needed to write it like this. Oh, sorry. I believe it should be here, like this. This is enable. Yeah, I need to have a space between them. Yeah, now it's good. So I can write it here. I can turn them off for access. I can change just the access number with access 3 over here. Oh, sorry. I can change it to access 3 off. Okay. Now if I turn the master enable, or by using the watchdog equal on, okay, you see the master enable getting enabled, but actually the servo is not enabled. Let me show you. So this is motor. Okay, you see the shaft is loose, so it's not enabled. Okay. Okay, so once I return back here and type in access 3 equal on, now the shaft is locked. So I can move it around.
Okay.
But the other axis, which is stepper, just here. The other axis, which is stepper motor, let me run, is still loose. It's not enabled.
It's not.
Why? Because it already made it disabled. So I can how I can make it enable is just choose the right axis, okay, and turn it on. Now if you see here, it's turned on, so I can move it. So this is the way actually you can enable the axis one by one or in a group over EtherCAT, basically. Okay. So it will give you the option to enable some specific access based on your requirement and disable some of the others if you need. So you can have more flexibility on the controlling each axis one by one. This is the command actually you need to use in your program, and even you can use it here.
Definitely.
Yeah, but this watchdog need to be on for sure, because this is kind of the condition for that, precondition. So if you don't keep the watchdog on, actually these commands cannot help you
Oh,
because these are in series. So this is a precondition and need to be on to give you the control over this command.
okay. So watchdog
And
or access enable? Just one, right?
yeah, these two are and together. It's not or, it's and. So
And
the watchdog is a precondition. It needs to be enabled to give you the functionality to enable or disable by using this command.
okay.
So this is the second one, and this is the first one. This is the precondition.
Oh,
Need to be on.
condition.
Okay. So you need to have this little yellow button over here on by using the watchdog equal on in your project. Okay. And then you can have flexibility to use the axis enable equal off or equal on based on the axis number, so you can separately enable or disable different axes. Not all of them at the same time, but separately. Or you can do it, at the same time, but keep all of them on for the axis enable command, and then watchdog can turn on and off all of the axes at the same time. So there is a combination between these two. You can play, whatever you want with these two commands. Is it clear?
Yeah, clear. Perfect.
Okay.
Okay.
Nice. Any other question on this program?
No, really. I understand how works the connect.
Did you try to connect two virtual axes at your end?
Yeah, I tried to connect with the radio.
Okay.
You make a move,
Yeah.
absolute move, and with the axis follow the master.
Yeah.
So it is only function.
Yeah, that's very easy. I have a videos. Yeah, I have a video somewhere. I'm not sure if I shared that video with you before or not, but this video actually I provided for one customer in the past,
Okay.
and that video shows how this function, I mean the connect function, working. So let me bring you this video. Not here. Trio training videos. Customer support. I can find it later for you. I'm not sure where it is. I think I paused. Yeah, I paused the video. Okay, so in terms of the frame, actually we have many frames here. If you go to the help one.
Oh.
So these are the list of the available frames.
Oh, very nice.
So this is one. This is also very popular. This is the HBOT. Yeah, which is a single belt mechanism.
Okay.
With two axes. So you can move the load, which is the end effector again, up and down based on the move command after setting up the frame. So it will be based on the load position not the motor
Right.
positions. And the controller will calculate automatically. Okay. So we have, this is different mechanism for pick and place with the arm.
Nice.
Yeah. This is what I showed you.
Yeah.
Okay.
Okay.
So it will ask to give some offsets, the link lengths, the angles,
Yes.
yeah, in this table, and that's it. So you're just setting up these parameters, running the frame, and controlling the end effector.
In effect.
Yeah,
Oh, great.
very easy.
Let's
Frame
see
13, you
that.
see?
Very, very nice.
Yeah. So that video actually shows how this frame is working.
It's working.
This is exactly
Mm-hmm.
the same frame.
Okay. Oh, we have to make that demo.
Yeah.
Okay. Very nice.
I didn't capture the video, so I just played the game.
Mm-hmm. Mm-hmm.
This is exactly the same mechanism.
Same mechanism.
You see that?
Yeah. Mm-hmm. This is it. Nice.
And here actually is the actual program, sequential program, and then this is for counting the steps, just to have a track on the step, and this is the output number 8, which is activating
Yeah.
each time. Output number 8, you see?
Yeah.
Over here.
Um,
And then on the startup axis, you see after everything is done, we're running the test program, which is this one at the end,
okay.
and it will automatically run the program for us, the final program. But before that, we have
Okay.
this parameter setting, which is the link length and everything we need to set on this table over here.
Okay.
Okay. Yeah, like this. So
Okay.
yeah, so we have kind of the setup process for that. Okay, let me scroll it a little bit. So this is the setup process. If I just run it from the beginning, actually we set the units, the access parameters, and then for the base 0 and base 1, okay, after that base 1 first, and then over here we do the homing while still the frame is not activated, okay, and after homing finish, I mean complete the homing, we will start the frame. So you see we set up the tables, the values of the table, and then we activate the frame 13. So the frame 13 actually read all these values from the table, which is the link length and the parameters, and after everything is done, we'll run the test program, which is the other program, and start the movements. This is the test.
Mm-hmm.
Yeah. So everything will set based on the end effector orientation.
Yeah, vector rotation.
Yeah.
Very nice.
Yeah, this was another thing. Let me just find that video for you quickly. Video shows how to change the ratio on fly on the same demo kit that I showed you, that frame thing. So yeah, that's also very good example for you
Yeah. And
to learn how to use that gearing function. Okay, so what did you test on top of the gearing?
yeah, I tested in mm, my simulator works well.
Okay. How about the other engineers? Did they have any question?
So, I don't know, Carlos. Yeah, it's very easy. Honestly, I like a lot. It's just we just have to have it in our hands.
Yeah,
So
I believe. Yeah, I believe. Yeah, I believe Shannon shipped out on
excellent.
Friday. I saw the email from Angelica. Yeah, she asking about the tracking. I think you can find the tracking on the invoice. Have you received any invoice from us by
Angélica,
email?
Angélica, ¿te han mandado alguna factura?
I think she has. I think she has
Oh,
some issue with the mic, so I couldn't hear her at the beginning. So I think it's still the same problem for her. So she's trying
okay.
to type.
Let me check if
Uh,
we have received some invoice. Mm.
okay, she typed no. She didn't receive
Okay.
the invoice.
No, we didn't receive any. Oh,
Uh,
yeah.
yeah, I see.
Okay.
Yeah, you see her also. Yeah. So I will chase this with Shannon, and I will send you the invoice. So on every invoice, actually, we have the tracking number that you can track the UPS uh, and shows you the status of the shipment. So I think you have your forwarding in Texas, right? Texas state. So I recall you gave us an address in Texas to ship the items to them, and then they will carry it to Mexico. Is that correct? I can't hear her. Laredo is to invoice tracking number 0. I didn't receive it. A border. Okay. Okay, good. I will chase that invoice for you and get the tracking number, and I will send it for you by email. Okay. Getting back to our tech discussion. Any questions on this part? Can you hear me, guys? Okay. I see Angelica said she needs to practice. Daniel, are you there? Connection. Oh, okay. Okay, hold on, please. I am in the meeting. Uh, I believe you hear me out over there. Oh, Daniel actually lost the connection. Yeah.